complex problems. So when you look at why F# is appealing in different kinds of domains, one area where it is particularly appealing is in quantitative finance, and not in every aspect of a bank's IT operations, but particularly where there's the more mathematical side of banking programming. F# seems to be particularly appealing there. And we spent quite a long while thinking about, well, why does F#, why does it fit so well in that kind of work? And the kind of work in that domain, and there's other kinds of domains where F# is also very appealing. The kind of work in the banks such as Credit Suisse is about programmatic modeling. It's about using a typed, efficient scripting language to kind of to first of all to compose existing components of mathematical models so you might be modeling, say, some of the financial instruments, such as derivatives instruments, and you've got some good components around, perhaps they're written in C++, and you need to kind of put them together in interesting kind of ways. But you also need to be able to make components that actually can integrate into the overall software environment that you're working in. Now, that might be a COM-based environment. COM is still very common, and one of the good things about .NET is that you've always been able to wrap up .NET components as COM components and sort of deploy them into real-world environments. And it's a similar thing with F#. F# is just .NET, so whatever you can do with the .NET component, you can do with an F# component as well. And there's something about this mathematically oriented language which plays to different roles, a practical mathematically oriented programming language. It plays to, say, quants to contribute components. Architects can explore hard problems. So an architect may be exploring a design for a parallel, incrementally updating engine. Now you're going to have C# user interface around that. You're going to have Visual Basic user interface. But the architects are sort of the architects are back in the coding game in a way. They can crack out the code and they are designed for a difficult problem in the programming space, and then hand it off as a .NET component to be then taken further. And developers themselves can handle parallel and async, and it's just a very good programming language for general purpose programming as well, general purpose mixed object-oriented functional programming. So when we see different boundaries, say on one axis you might have things like C++ and the native languages, and then the C# and Javas. F# is up there with on the performance side of things, right? If you write like-for-like code in C# and F#, then F# will be at the same performance as C#. Often F# is sometimes F# is slower. There can be sometimes F# is faster. There are various case studies around on that. Not kind of like official case studies, but you can look for the anecdotal evidence here. So it's deliberately designed to have a good performance profile from the start. And the strong typing of the language means that it does have this sort of professional development tools. You get IntelliSense, you get red squigglies, and you get all the kind of strong properties that you need for professional development programming. On the other one, on the other axis, there's a matter of expressivity. Now, F# is not like it's not a perfect mathematical programming language. It aims to be a practical, pragmatic, mathematically oriented language. And so it kind of sits between the programming domain and the expressivity kind of domain. Okay, so the aim, that captures kind of the aims we're looking for. Succinct, expressive functional language, parallel, explorative, data-rich, and algorithmic. And if you think that F# is data-rich today, I'd encourage you to come along to my PDC talk, join it online, and take a look at what we're doing in what we're looking at for future versions of F#, and that'll really, really blow your mind about how data-rich a language can be. As I said, PDC talk on Friday afternoon, where we're announcing we're describing some potential future F# features. So we also see ourselves as a language, as a team here at Microsoft, as being industry and platform leading. One of the reasons we're doing F# is to make sure the .NET platform stays really alive as a set of ideas for how you can how you can work with how you can leverage .NET in really interesting ways and in sort of new domains and for tackling new kinds of problems or old kinds of problems in new kinds of ways. And so it's absolutely not a replacement for C#, VB, C++. There is a sense in which as we do things in F#, there's a definite tendency for the C# guys to take a really good look at what we're doing and to learn from it and to look at how that can be integrated into C#. That doesn't mean that that's a good thing. It's one of the reasons why we're doing F#. You'll see some really interesting things being announced by Anders. If you go to his PDC talk online at his PDC talk, I think that's tomorrow. Take a look what they're doing there, and that's definitely good, really good stuff that they're doing and inspired by F#, and that's great as far as the F# team is concerned. F#, since it's not a replacement for C#, F# lives by C# being successful and by .NET being successful. So we're all, in a sense, we are very cooperative in that way. All the teams, the same with Visual Basic, we're all very cooperative in that we all know that it's fundamentally about the success of .NET and as a platform in the long run. Okay, so it is a multi-language platform, and I think we've landed F# in a nice niche in the platform that augments the existing languages rather than attempting to replace them. So I want to talk about why functional programming and what it really brings. I'm going to bring out simplicity and parallel programming as two themes here. So simplicity, first of all, it's not quite functional programming, but often functional programming languages are associated with scripting. Typed scripting. I'm always talking about typed functional languages in this context. And here we have a little script, and then here we have a corresponding, say, C# structured object-oriented program. You can see there's a correspondence between the two. The point I'm making here is that the F# program starts out assuming a sort of an explorative mode of working. The C# programming assumes a structured object-oriented program approach to working. Both are fine. I'm not saying necessarily that one is better than the other. It's just it's saying which one comes first. In F#, it tends to be that the exploration comes first, and then you transition across to structured object-oriented programming. So we absolutely embrace OO. We absolutely embrace the .NET design guidelines for writing components. There's a set of F# guidelines for how to write your F# components according to the .NET design guidelines, and so this slide is not meant to say that one is better than the other. It's about just what comes first in the language. And I think everybody who's used these scripting languages agrees that the ability to just work in an explorative mode adds value to the programming experience in particular domains where exploration is critical. So here's just an example of an object-oriented design pattern. The C# code I'm going to show is not is basically Java-style C# code. Again, this is not comparing to delegates in C#, which of course is a form of functional programming. This is making the point between functional and OO, which is in a sense making the point for delegates in C# as well. And delegates and generics in C#, which of course I've also been involved in the design of generics for .NET and C#. So over on the right, you see the object-oriented design pattern way of expressing the logic that's on the left. You see that F# takes a simple declarative approach to it. You have a type command representing moving an action that moves the rover in some way. This is from a simulation engine of some kind, which accelerates the rover or rotates the rover. Then the structured gang of four design pattern way of writing this code back from the 90s is like this, and it's just, as you can tell, it's just longer. You have the rover command inheriting the command, you have the break command inheriting the rover command, put the rover in the rover, etc., etc. And you can see why, if the comparison is with Java-style programming, then the F# approach, and in some ways the C# delegate approach, is much clearer and much more succinct for the declarative intent of the user, of the programmer. Here's some functional data in manipulation in F#. You have a swap function, which say takes two elements and takes a tuple in and returns the element a tuple back. You have rotations here, which say gives me a list containing the 3 rotations of a tuple. Or you have a reduce, which takes a function. You can a delegate or a function and takes the three elements of the tuple and applies it to each element and adds them up. Simple, straightforward programming. It runs as efficient. It's strongly typed in F# because we do a type inference scheme over this code. So it runs as fast as the equivalent C# code. So the equivalent C# code for this kind of thing you see gets kind of long. We have a swap, we have this read-only collection, we have a reduce function here, we have all these generic arguments that have to be declared in positions, and you can see that this is kind of not hitting the sweet spot that if you want to do loads of the programming on the left, then you're not quite hitting the sweet spot with the code on the right. That said, C# got a great system of generics, so I worked on it. It's a great language. It's just where we're looking at making certain kinds of programming, hitting a simpler spot in the spectrum. Here's an example of an embedded domain-specific language. This is a language for propositional logic. You might use this in, say, analyzing a circuit in a hardware design pipeline, and just represent the gates in the circuit description. And here's the corresponding C# object-oriented design pattern implementation of this. You have some abstract class, and then you have a unary operators and binary operators. You start to kind of factor things in this object-oriented inheritance kind of way. Then you have your trues and ands and nands and so on. And you can see again that the language, when you're expressing an object model for a domain-specific embedded language, then the one on the left can be quite a lot simpler and quite a lot more declarative. Okay, here's another one of the same kind of thing that is more of a practical example. It might be instead of finance industry where you have, say, price split dividend, and you have the corresponding C# code to this object model as well. Okay, so F# is kind of friendly and simple for another reason, in that it's built on .NET. You can write standard .NET components. It can plug into any of the applications. It can plug into the SQL Server the pipelines in the SQL Server information services, and or you can use it as plugins to tools like AutoCAD, or just the whole thing with .NET components. They can sort of work anywhere. Okay. So let's talk about parallel programming. We have a simple compositional model of asynchronous parallel programming. So you might be doing 3 web requests, doing asynchronous HTTP GET on these things, and you want to put these in parallel. You just do it by expressing the composition and then pressing run synchronously on this by piping the composition into the run synchronously operator. Similarly, you might have a set of CPU tasks like this, and you want to run those in parallel. The first one was an example of an I/O parallel problem. You might be getting, say, 1,000 web pages in parallel. So that will be limited by the number of open web connections you can have at any one time on your machine or through your network, or may depend on other network characteristics. That's an I/O parallel problem. And F# is beautifully set up, a real industry leader in having a consistent a single model for dealing with I/O parallel problems and CPU parallel problems. And the unification of these two in F# is absolutely fantastic, and you'll see, I think you're going to see a lot of other languages learning from this and adopting this kind of model. Okay, so when we look back to the history of F#, to give you a sort of frame of reference for it, there's a set of functional languages which come through the OCaml programming language tradition. You can trace the influences back to languages like ML, and Haskell is also in this list. And then there's a set of traditions, the object-oriented languages, which C# and its heritage from C++ and Java and the like. In a sense, we're unifying these two languages by taking a core functional model from OCaml and an object model from C# and .NET. Okay, so I just want to show you a little bit of a demo here from using F# in Visual Studio 2010. Let's just close all of this here. So I hope everybody can see my screen okay. I'll just take a quick look to see if we got any questions so far. Once I found out where my live meeting is here. I guess, yeah, quick Q&A. Let's take the Q&A. Okay. So, got a couple of questions about are F# elements always static? And is there any IntelliSense for F#? And questions about, maybe I can click on this, combining F# and C# code inside a single project. Okay, I'll take those questions out and try and answer them as we go along. So what I'm going to do is reset this session down below here. And we're going to, so I've opened up the window, this F# interactive here. I've got myself a new script. We're going to be doing a lot of scripting in this presentation. You can also create a project, and you can create an F# project. You will have seen that in the Visual Studio menus if you're using Visual Studio. And you can create DLLs, you can create executables just like in C#, but there's also this sort of scripting mode where it's indicated by the use of a different extension, this FSX extension. And in that mode, you can load up other scripts like we've done just now. And the scripts I just loaded give us an object type called a Twitter stream. And they also declare a username and a password here for the stream. And what we can do with this Twitter stream, just to answer the question about IntelliSense, then you can see we can get IntelliSense here. And we can see we have a new tweet object here, which is an event, returning an event of strings. So we're going to get a stream of strings coming out of this Twitter stream. Feeds the XML one tweet at a time. So let's take a look at that. First, I'll do a couple of other things to orient you a little bit about what all these pipelining symbols are. So let's create some data first of all. Let's create the numbers from 0 to 99. Actually, we'll create the tuple 1, 2, 3 first, and call a function called show on that data. We could just take the data, and I highlight the data, and I go Alt return on it, and it's evaluated in this window, the F# interactive window down below. And you can view that window by view other windows, where is it? Or view F# interactive, or if you're not using the F# developer profile, it'll sit under the other windows menu here. Okay, so we can also call the show function on this data here, and you can see that that's actually showing it up into the form on the top right-hand corner. The show function is defined in the show.fs script here. One thing you'll see us doing quite often, well, first let's show the numbers, say, from 0 to 99 here. Okay. So we've taken a list of numbers from 0 to 99. What we also often do is use this pipelining notation, which just says take an object here and show it in the window, pipe it into the show function here. So we're taking the object and we're piping it across into the window over on the right. And we can do this with the data here as well, show 0 to 99 and pipe it across over to the right. Let's put this away here. Okay, now I'll create a new form. So we'll open system.windows.forms. And we'll create ourselves a new form, visible equals true and topmost equals true. I often use Windows Forms for ad hoc visualization like this, rather than using WPF. Now, what I'm going to do here is I'm going to take the click event on the form, and I'm going to add a handler into that, like this, so add. So just adding an event handler, and every time the event gets raised, I'm going to print, actually what I'm going to do is I'm going to take the event args here, which I'll just call E, args, and I'm going to show the args.x and the args.y. Okay. Yes, I need actually the mouse click event here, rather than the click event. Okay, that's right. Okay, and now every time I click on that form, you can see the different shows coming up over on the right. So let's do that again and put it in a more functional style. So what we're going to do here is we're going to take the stream of events coming out of the click here, which is called an event, and we're going to map over that stream. This is a bit like link to events for people who have used that, or the RX framework in C#. We're taking events, first-class events, and then you're transforming them. And we want to say we're going to map over to extract out the X and the Y arguments. And now once we've got the point, the pair that represents the point, we're going to show that point here. Okay. And we can make it simpler by just typing it called the show function. So we're going to iterate the event stream and put it into the show function here. Okay, so that's called event.add show. Okay. So now we create ourselves a new form again, and we'll take the mouse click event, and now every time we click again, we get the same behavior as before that we show the points over on the right. So you can see we're taking an input stream, we're doing a transformation over it, and we're visualizing it over on the right. Now we're going to do that same thing with the Twitter stream. So we get ourselves a Twitter stream, and we're going to get the new tweet event, and we're going to start adding a pipeline of processing of what happens as we get tweets coming in from Twitter. So we do a new tweet, and we add the show function here, and we can see we're sitting on the network here, and we're listening to a stream of tweets, and as they come through, we're displaying the XML that comes from the Twitter service. So now we'll stop listening to that here. And now we want to do things with that pipeline along the way. There's obviously all sorts of pipelines we might want to set up to take this stream and to kind of push it in different directions. And what we're going to do first is we're going to map over a parse. We're going to add in a step that parses the tweets along the way. And then we do the same thing, we show them. And this parse tweet thing takes the raw XML here, just good .NET code, which takes the raw XML, the string, and returns a user status. It returns a user status option, which means it may or may not succeed. Option is a kind of nullable, sort of a generalized version of nullable in C#. And we can take it, we can press F12 here to go across to the definition. You can see how it works. We have our XML document parse. We do get the document root, and it's just straight up .NET coding over the XML. Okay, so let's stop listening to that. And now we're going to start doing some other things in the stream. So the first thing we're going to do is index the stream by, say, username. And you can see the usernames up here and the statuses and the tweets that are coming from the different users. The next thing we're going to do is we're going to work on the words here. So we're going to take ourselves a little function, make a little function called words, which given a string gives us the words in the string. And we're going to say test that. We're going to take this phrase, all the pretty horses, and we're going to split that into words. You can see that F# is very oriented towards a test-driven development kind of methodology, where you write some code and you test it immediately, and you get these fragments of code that are working. And one of the sweet things about functional programming, typed functional programming, is you build these correct building blocks. You know, things such as these event.choose, event.indexBy, event.map, and so on are correct building blocks. And you're composing them together, and it's that compositionality which leads to a low bug rate in F# programming. You're building correct programs out of correct building blocks. So let's do the word splitting on the status field of the tweet. So we're getting the words in the status field of the tweet. We might change this to be called tweet here. Okay. So we get the stream, we choose the successful parses, we get the words from the status, and we do something with the result. We visualize the result. Now we, of course, we actually say we want to count the occurrences of different words. So it's all the same pipeline. We're doing a choose, then we're doing a map, and then we're doing an incremental histogram and over the words, and then we're going to visualize it every 10 tweets, which means we drop every nine tweets, then we 9 histograms, and then we get a histogram, and then we take the top 50 entries from the histogram and show that. So let's do that. Okay, so you start to see as the data stream builds up the analysis of the stream, then you can see the different words which are popular here. You notice retweet here, it's very high on the list. Okay, if someone was asking a question, then I'm afraid the audio is really not working well, but I think the questions are going to have to come out through the Q&A. I didn't hear that what was being said then, so pop it in the Q&A, and I'll pause in a moment and we'll have a look. Yeah. Okay, let's take a look back at our slides here. Where are we? Right, so we've done some event programming. Okay, so this tradition of F# being about a mixture of functional and object-oriented programming is very central to the methodology as well. In a way, C# has some similar language features. It's an object-first language with a functional element to it in link queries. In F#, it's much more a functional-first language, and then you shift towards an object-oriented style and in production code as you make components. So the role of object-oriented programming is different and reduced, but it's still very, very important. And this does match interesting methodological issues, which is that you start with functional programming. We often think of F# as a functional-first language. You're starting with an idea, you're starting in a conceptual space like the one we were doing. You're building up your analysis over these Twitter streams, and then the question is, you then have to transition that towards realistic code. Often the functional code can be perfectly realistic code. For example, in the kind of problems we were working with there, you would almost certainly be I/O bound and not CPU bound. And so you don't need to even think about optimizing anything or making anything imperative. You might want to do some object-oriented programming to encapsulate what you do. But it's not necessarily about optimizing some of the functional programming out of the equation. Functional programming can be highly efficient in many situations, but there are sometimes, as part of the standard F# methodology, there are sometimes when you would transition to use imperative programming as part of your standard methodology, based on, say, profiling run, or based on some intuition about where the bottlenecks are going to be in say, allocation. Okay, I want to go through some examples of how F# is actually used in practice. What we've seen so far is just like a little scripting thing, but what I want you to imagine is taking what we've done and transitioning that to be a machine learning engine that sits on, say, the Twitter stream and learns data about, say, about word frequencies in the text, and uses that data in, say, for a trending topics analysis space over the stream. And then you build a web front end to that engine using C# or Visual Basic, or you build a actual application, or maybe you're just interested in some numbers at the end of the day. That your end deliverable is a report on the latest trending topics in Twitter. So in this example, it was written up by a guy called Simon Cousins. He was working at a power company, and he was balancing the power generation schedule in the UK for a set of power stations. And the role that F# played, it's very, very common in this way, is that the role that F# plays is as the calculation engine. And from his point of view, he's using F# to address the complexity at the heart of the application. And that is the sweet spot in .NET for F# 2.0. Algorithmically complex analysis over large data sets. There are other sweet spots, I think, as well. I just pulling this one out because that's often some of the most significant deployments of F# have this kind of characteristics. This is an interesting case study because Simon wrote up why F# was so effective for him on this problem domain. He wrote this engine, and it was deployed, and he thought, I'm not hearing back from these people. What's going on? And they're probably not using my code. And he gave them a call, and in fact, there had been 0 bugs in his code in the delivered engine, and he said that is unheard of in this industry. And that, of course, the experience is not always like this, but anecdotally, we do get that report, or just positive reports about the low bug rate in F# code for analytical, engine-oriented code, again and again. And I put that down to to what I was just saying about you're building correct programs out of correct building blocks. So Simon wrote up some of the particular features that he saw were critical in his domain, and some of the particular reasons why they worked well in practice. Interestingly, he rated the F# feature units of measure, where you can annotate floating point numbers with annotations like, does it represent money? Does it represent kilograms? Does it meters per second? And the like. He rated that as one of the most important features. That tends to be a feature which is, if you're working with numbers a lot, it's absolutely critical. If you're not doing so much numeric work, but you're working with XML literals or XML data or the like, it's not as important. But when it works well, it seems to work extremely well. And then he lists the other reasons here: the parallelism, the unit testing, code reduction, lack of bugs. And he wrote this up, and this is up on Stack Overflow if you need a reference here. So the interoperation here is an interesting point. Interoperability for languages tends to be talked about in terms of the language being able to consume everything else. Okay, that you have, say, IronPython, which can consume the .NET libraries. Something that was really important for us right from the word go with F#, it goes through the entire, many design decisions in the language, is to make sure we can wrap up F# code as .NET components, and that the C# programmer doesn't need to know that F# is being used. There's 2 levels of that. One is to make sure everything in the public API of an F# component is compiled in a specified way. The other thing is to make sure that there are a set of guidelines about if you do use some F# specific features, F# asynchronous programming or F# units of measure, then you know what you should be doing with that at the programmer boundary. So interoperability, both out to .NET is an important thing, but interoperability in making components that interoperate is critical as well. And that leads to interesting deployment characteristics. One thing we notice is, F# does get deployed in this way where people package it up, that people don't know that it's being used at the boundary, and that is fantastic for enabling deployment inside organizations, because what it means is you can have a small team of programmers, team of 1 or 2 or 5 or 10, however many, make these F# components, and nobody else, in a sense, need know that they're done in F#. That is, of course, you see it as you debug through, so there may need to be some educational basic level of knowledge about F# code, about the kind of problems it's solving and why it's being used for a problem. But one interesting characteristic is that enables realistic deployment, but it doesn't make the deployment virally infective. So that means you don't have to convert your whole organization over to use F#. You just have to you can take it one step at a time in the adoption of F#. And we see that as a very good thing. It does mean perhaps that we won't see a hype cycle. I hope we don't see a massive hype cycle around F#, where everybody says it's going to solve all the world problems and then we discover that it doesn't. Instead, I want to see sensible, rational deployment and use of F# in the places where it makes people more productive and solves real problems in cases such as in the case study I'm showing just here. There's a couple of case studies written up on the Microsoft site. On Grange Insurance is one. They've been very happy in their use of F#. They've taken time with Microsoft to write up why it was effective for them, and that's a combination of all the features. It's very, very similar to the write-up that we have on this case study. It just applied to a different industry. There's a company, this is a write-up again. Unfortunately, this one had to be anonymized in terms of the company, though many people have been following F# might know which company it is. A company using F# quite very extensively, and it's been extremely effective for this financial services firm. I quickly talk about another case study, which is Microsoft adCenter, or in particular Microsoft Research and the components that they've contributed to adCenter in the form of machine learning algorithms to improve Bing's click prediction for ads. This is an interesting application domain. It's about taking massive amounts of data, 6 terabytes of training data, which at least back then was enough that the teams in Cambridge, UK, couldn't actually download that data. They had to get it flown over in hard disks instead. And there was an internal competition to improve the click prediction performance of the analytical engine in Bing. And click prediction is an absolutely key factor of online advertising. If you know in response to a search term which ads are more likely to be clicked on, that's a measure of their relevance. So it's the same sort of problem as if you have the sports section of the newspaper, you don't necessarily put ads about the opera in the sports section of the newspaper. You want to put the right ads in the right place so they're relevant to the people who are watching, to the people who are consuming that information. So this was building a massive machine learning model. The people in the project were not professional programmers. They were machine learning experts, and they built a maxed out a 64-bit machine with this enormous arrays of probabilistic variables. And the aim in the end is to improve the performance of the ads that are placed in Bing. They won the competition, and they were extremely successful in their use of F#. They were the only, out of the 7 teams that entered at across Microsoft Research, they were the one who ended with by far the most realistic code, in the sense that it was sort of ready for deployment pretty soon after they had finished. It took a bit longer for it actually to be deployed to Bing, but that's often the case. As I watched them during the 4-week cycle, I was kind of thinking, why is F# working for them so well here? We didn't design F# to do machine learning probabilistic analysis. We designed F# to be a good functional programming language for .NET. And so what I noticed is that the type inference was wonderful for them. It just meant that they could concentrate on their domain and do more thinking, rather than concentrating on getting the structure of the software, sort of the object-oriented structure of the code, correct. Of course, you have to pay attention to the object-oriented structure, especially if you're going to turn the code into production. But the quick coding and the type inference means you stay in your domain. And F# in many ways, the places where it's successful is in these more domain-oriented programming problems. Agile coding, the type info code is easily refactored. It's a very fluent way of working. The scripting was important for them. The performance of .NET, and in particular, the performance of .NET generics here is critical, because the thing about .NET generics is that you can create, well, there's a combination of things. There's generics, there's .NET, there's generics, and there's structs. And the fact that you can create these arrays of structs and you know exactly how much memory they're going to be using. You're not just stressing the garbage collector at every single point along the way if your basic core massive data structures. This is really important in this kind of work. So we have immediate scaling to massive data sets on .NET, and living in the domain, not the language, and they also use the sort of more language-oriented programming, DSL kind of capabilities of F# in the schema compilation and schedules, and they use the .NET integration with Excel and SQL Server. Okay, so this is a paper, if you'd like a reference on the actual algorithms that were being implemented and their successful use in Bing. It's not particularly focusing on the role of F#. It's a scientific paper focusing on the machine learning techniques. Okay. Bing have made enormous improvements. There's not necessarily a direct correlation. There's many improvements that have been made in Bing's advertising delivery. But I think Microsoft Research are really proud of some of the results that they've been getting through that the online services groups have been getting. This was just taken from a random screenshot of a news report, but it's not particularly to be taken seriously. But just to say that the Microsoft Research have been using languages like F#, using machine learning techniques to make really major differences to web scale industries. Okay. Let's take the Q&A now here. Okay. I'll just run through them and keep jumping in with more questions along the way, and then I'll continue on with some more parts of the meeting in a moment, of the presentation. So the question is, intelligence for F#. I think we've seen this one, so I'll put a little tick on this. Okay. Right. I guess I'll answer that. Let's take a look again. Okay. So is F# more performant than C#? Does it execute code faster? So the answer to that is that they're both compiled down to the .NET intermediary language. So in a sense, they both have the same performance characteristics in the limit. For like code, you can more or less write C# in F#. You could more or less write F# in C#. You could write them in .NET IL if you like, and you'd get the same performance. So it depends really what programs you're actually talking about. F# has some things which turn out to be highly performant. You can have inline functions and you can have inline arithmetic functions that get specialized to the different types as necessary, and they can be performance. They can be very, very performant. So there are cases where F# code won't run it as efficiently as C#, but that'll be perhaps a different way of solving the same problem. Okay, the thing about combining F# and C# in a single project, that is not possible today. I understand that would be a desirable thing. At the moment, languages in .NET are a project-based granularity, DLL-based granularity. And the problem with putting them in the same project is you then have to basically intertwine the two compilers. You have to you can't even do that with C# and VB, which are technically very similar languages. So intertwining languages to that extent tends to be a little too difficult. It would be possible to implement it, but you'd basically have to rip apart all three compilers and completely re-architect them. And that tends not to be possible in practice. Okay, I'll mark that one. Okay. Shall we do these then? I'll just do them in the order they came in. In my experience, do you find that people can make the transition easily from C# OO style coding into F# and their functional style? Is it just the case of buying my book on F#? Actually, my book, funnily enough, is not the one I would recommend to start with. The book I would recommend is Programming F# by Chris Smith. There's also some excellent online books, and there's also some excellent, there's Beginning F# by Robert Pickering is another great one. And the question about education and learning F#, I think we've seen many C# programmers successfully make the transition to F#. We've seen some people struggle. Some people say, I just got no idea what this, why I would want to use this, or what is it for. And usually when we take people through and we say, hey, it's not for line of business applications, it's not for your WinForms or your WPF web apps, maybe for the engines that sit inside those applications, then people start to realize that it has a limited role of use, so it's not a replacement for C#. And then they take a bit more time to learn it from the ground up, and that people then can make the transition. We've certainly had lots of experience of people who don't know C# and OO can pick up F# very quickly. So in some ways, It's a bit of a phenomenon sometimes that can't teach an old dog new tricks. Sometimes people don't want to learn new things. They're very, very comfortable in their C# zone. That's fine. Usually that's fine. They're being very productive in the work that they're doing. No need to change things. Just one happy family between C# and F#. The code can coexist. So can you deploy an F# library with the Silverlight application? Absolutely. I'll run through a couple of points about practical things like templates in just a moment. And that's the next question as well. We'll take a look at the online templates. Language elements that help with system programming, such as calling Win32 API and COM directly or working directly with memory. Okay, thanks. That's a good question. C# is in some ways better set up for doing what you'd think of as native interop programming. You can do native interop from F#. You can declare P invokes, and you can consume the COM components directly, just as you can from C#. The COM API, the TLB import components. Now, you can also do, there's some unsafe operations you can do, just like in the C# unsafe language feature. It tends to be, because C is designed as a systems programming language, then in some ways the C# code will be more familiar to people who have done C programming. And often you'll be taking a snippet of C code and translating it across to C#. So you can do it from F#, but it's just something that enables modes of use. It's not the thing that makes F# sweet for that. It's not particularly sweet kind of programming. It's just necessary. How is F# deployed? It is in DLLs. It is in compiled code. You can use a command like compiler. You can use a project to create an F# DLL, just like in C#. Okay, then there's a quick question about the analytics in comparison to C#. Well, C# as it comes from the language point of view, as I said, they're like for like in performance. In fact, F# through this inline arithmetic feature that F# has, then F# can actually be faster for analytics, depending on how you write your code. Now, normally in a financial analytics situation, you'll be sitting on some other .NET libraries or some C++ libraries that do the heavy lifting in your analytics. And you'll be composing them using C# and F#. And so in that case, both C# and F# have the same performance profile. So the real answer to this question is it is the same performance profile, and sometimes better with F#, and it depends on how you're writing your code. Okay, so Maxime has a question here about interoperability and making that transparent with F#. So currently it feels like it's quite hard to make interoperability transparent with F# in use of interfaces, etc. Is it something to be addressed in future versions? So we have a set of design guidelines, which I'm not sure if Maxine, if you're familiar with those. So I'll bring those up. If we search here for F#. Here we have these draft F# component design guidelines hosted here. And so I'll initially point you to that document, and if it doesn't answer the questions sufficiently, please do send us feedback on that document and let us know what other questions you'd like addressed or where you think there are concerns. The usual guideline is you will do some object-oriented programming to help wrap the components. That is an expected and standard part of wrapping up your F# code. And you would hide the fact that some interfaces may be used in the implementation of F# code. Okay, and I think this is a question about referencing F# projects from C# projects, or an answer to an earlier question about combining F# and C# code. I think the question was about combining it in a single project. You can, of course, use an F# project from a C# project without any problem at all. Okay, so there are some questions there about templates. So what I'm going to do now is go across to the online templates. So let's go to open a new project here. Okay, so when we go down here to F#, actually we'll click down. What I want to do here is, when you get Visual Studio 2010, you get a very limited number of templates with F#. You get basically two, or three if you include the Silverlight templates. But if you go to the online templates, then things start to get a lot better. So type in F# into the search box on the online templates, and you'll see that things are looking a lot more familiar to the C# programmer. I'm not quite sure. This first one is a very thin template, so do look at the ratings here. This is not such a good rating. But if you're looking for templates for phone, for standalone F# only web applications, if you're looking to implement OData feeds with F#, then all these templates are here, and they're working. They're very nicely done templates. A lot of them have been done by an F# community member called Dan Mole, who's done a really great job of packaging up these templates. Some of the templates match the methodology that we talked about, which is a C# user interface and F# sort of code behind that user interface. So we've labeled those ones as F# and C# for the various front-end technologies here. If you're interested in using some of the tools, we come with what's called the F# Power Pack. There's the tools called FSLex and FSYAC. There's also a template here for getting started with that. Okay. And we have a new template here that I haven't seen, a nice little panorama template for the phone. Okay. Okay, so time has gone on. Things have gone a bit faster than I thought. Time's gone a bit faster than I thought. So I think I'm going to skip over these fundamentals of the language, and I'll skip over the 3D simulation demonstration because that won't work so well on an online presentation. I do want to point, because I know we'll have a lot of C# programmers online today. I want to point you to the F# Object-Oriented Quick Guide. Again, just search for this term. It's also one of the standard resources that are available from F#.net, the MNSDN Developer Center for F#. This quick guide is nice because it gives you, first of all, there's the basics of how you do objects. Like this is the sort of the basic structure of an object definition, class definition in F#. And that's how you construct an object, and that's how you define an interface type down the right. Here's some examples of what a class looks like. Just ignore the red squigglies. I'm not sure why they came up in these screenshots, but we have a type vector here, which takes 2 arguments, and you publish those as members. There's a corresponding C# code over on the right. Not that you could, I think, use the more the C# property syntax to make that more succinct. But that's, you can see the correspondence between the two code fragments. This might be a class. The object-oriented quick guide just takes you through all the things you might do with C# object-oriented programming and tells you how to do them in F#. So sort of how to do classes with multiple constructors, how to have some private members. So this rotate function here will be a private member, and that will be the corresponding C# code. And they take you through all the other things you might do with object-oriented programming. To be an effective F# programmer, you don't need to know all of these things. You can get a long, long way with F# without actually doing a lot of object-oriented coding. You might be using object types coming from the .NET libraries, but not actually, that you may not have to do much object-oriented coding, or if you do, it might be a sort of simplified version of object-oriented programming. But sometimes you do need all of these things as you design frameworks or as you design class libraries in the nicest possible way. A tiny bit on your units of measure. Here's some examples where you define some new measure types. So this is like defining a new measure like kilograms or meters. It's an attribute that you can attach to your numbers to say that actually, as we have a data type here, a model of prices in a financial application, then you're annotating that this floating point number is some kind of money. This floating point number is some kind of volume, and you're using those tags to track the types of your numbers all the way through your code. F# asynchronous and parallel programming, we won't have time for today, so I'll skip over that part of the talk. F#, I just mentioned quickly that F# just has a very, very nice model of asynchronous programming, where you can have these asynchronous fragments, and you can specify reactions to events such as GUI events and timer callbacks and web service responses and agents getting messages. And the combination of F# functional programming and async programming leads to some very, very interesting application areas, such as parallel programming. I'll skip over these here. Server-side programming. That might be something like having 5,000, or actually on a 64-bit machine, 50,000 simultaneous TCP connections with managed only with a small number of actual .NET threads. And you can write very declarative, succinct, asynchronous processing code that will run efficiently on these servers. And finally, the F# and asynchronous programming model lets you do agent-based programming in the style of Erlang-style actors. And this is what an agent definition looks like in F#. You might have an agent, and then you have a while loop that sits there waiting to get some messages, and then it prints out the messages that it receives. It's a little bit like a thread, but it's a much lighter weight than a thread. It's lightweight enough that you can have, say, 100,000 simultaneous agents on your machine waiting to get messages. Now, the only case where you need so many agents tends to be in the case I was mentioning before, where you're handling many simultaneous connections on a server. But again, these agents are lightweight enough that you can have thousands and thousands of them. And get the scalability properties you need for your server. Okay, so I'm going to finish up now. We're hitting the end of our time for the hour. We're shipped in Visual Studio 2010. We're going through the planning and early development process for the next versions of future versions of Visual Studio at the moment, and F# 2.0 is available in Visual Studio 2010. You can also use it as a set of standalone tools. Those standalone tools do work with the freely available Visual Studio 2010 shell, so you can have a Visual Studio coding experience by combining the freely downloadable shell with the F#, what we call the F# CTP, which is still available, which is available today for F# 2.0, in addition to the product in Visual Studio 2010. You can also use F# on Linux and the Mac, and in combination with this mono implementation of the .NET, the CLI specification, and we see quite a lot of interest in doing that from the academic community and other places. So, to summarize, F# is simple, it is powerful, it is productive, and it's meant to be an addition to the base .NET tools. It's really good for parallel programming, and a combination of functional plus this asynchronous and parallel language features just mean that it's beautifully set up for that, because it's also, parallel programming tends to be a very explorative kind of programming domain as well. You have to come up with an algorithm which captures the parallelism correctly, and then express how that parallelism is actually kind of coordinated in your problem. And so the interactive side of F# greatly helps there. And it is ready for supported use in enterprise. And I said, use it in the right kind of way. You can also use it for all sorts of things. People often use it for ad hoc testing of .NET components. They use it to trial designs and many other ways that you can use it. You can also just use it for regular general purpose programming. It is cross-platform as well, but ready for use in Visual Studio 2010. And some other things, we've released these community templates that you've seen. We have Windows Phone templates up there now, you saw those two. We updated the Mono Linux Mac .NET 4.0 shell free tools release in August. And November 5, we have an F# in Education workshop in Boston, and that's next week, and that will be actually streamed live over the web. And the final thing I should mention here is the PDC talk on Friday, and I'd love to have you drop into that talk and participate online with that one too. Some books about F#. We have Programming F#, a really good one from O'Reilly. We've got Beginning F#. It's more oriented towards enterprise developers. We have Real World Functional Programming with examples in F# and C#, a really lovely book by Thomas Petracek. If you're into, if you want to see it, my book that I wrote about F#, it's a really great book. It's called Expert F# 2.0. And I'd encourage you to take a look at that one. And we have F# for scientists, which is, and F# for technical computing, which tend to be for the more mathematically oriented or scientific and engineering kind of problems. Very interesting material in those books as well about interoperating with systems like Mathematica or MATLAB, or working with scientific data, and really lovely books. Okay, so we'll take the final questions, and I wanted to point people towards fsharp.net, my blog, and if you happen to be in the London area, which I'm not sure, people probably aren't, it's probably mostly West Coast, I'm not sure, but it's there's an F# London meetup group, and there's also quite a lot of F# groups appearing around different parts. And if you need to be put in contact with other F# users, then sometimes people contact me, and I post something on my blog saying, people are looking for F# users in Switzerland or other places. So just let me know, and I'd be glad to do that. Okay, so let's take we've got 3 questions here. So this is more of a functional programming question. This is from Jeremy. But are design patterns relevant in a functional language like F# or more for the OO languages? So design patterns are absolutely relevant to F#. Sometimes what we think of as the object-oriented design patterns have much simpler solutions in a functional programming context. In the sense, you can look at functional programming as being a language approach which builds in certain design patterns into the right down at the language level. What I tend to find is F# is a beautiful language for seeing a design pattern clearly. So as you might take a basic implementation of an architectural design pattern, less of the coding design patterns like the Gang of 4 ones, but more the architectural ones like MVVM in web design, website design. Yeah, that's a really good architectural pattern. And the templates that I was showing you for using F# with C# for user interface design, or just the F# WPF designs, they use the MVVM design pattern, and it's just a really good pattern. And so, yeah, it's a good knowledge of design patterns and a willingness to embrace design patterns in a positive kind of way. But maybe to look at them through a different lens, look at them through a clean, perhaps I think personally, sometimes a cleaner lens, then that it's cleaner and perhaps less complicated. There tends to be a lot of jargon associated with some design patterns, and we tend to de-emphasize that a little bit in F#. Then yes, I think design patterns are relevant, depending on the quality of the design pattern and how it relates to existing functional programming techniques. Okay, so the next question is about WCF and F# working together. Can I call F# code from C# code? And yes, you can absolutely call F# code from C# code. All the object-oriented code that I've been showing, you can call. You can also implement C# interfaces in F#, which is what you often have to do in WCF. And yeah, it's absolutely fine. Right, so now Joel is asking about, just curious, when you searched, why didn't you use Bing instead of Google? Yeah, that. No, my default is Bing. I'll absolutely say that. It's just occasionally I switch across to see what Google says about a search as well, and IE8 remembers the previous settings. So yeah, but good question. But no, I love Bing. I actually use it as my default all the time. Okay, so Vladimir asked about F# compiler sources will be published on Codeflex. Is that true? If yes, when this will happen? It's absolutely an issue we are looking at. We're doing active work inside the organization on that issue. We tend to, like everything at Microsoft, we tend to, rather than talking about dates ahead of time, we tend to rather to actually do things rather than talking about dates ahead of time. We think that's just clearer and better for everybody rather than having to come back and say, oh, we changed the date by a few days here, or we changed it by a month or something. So you can continue to gossip by all means, but we're definitely looking at making the F# compiler source available. If we do an open source release, it's not going to be the same kind of open source release as, say, I am Python and I'm Ruby. In particular, we're basically be looking at making available a snapshot. Basically, every time we do a release of Visual Studio, we would like to make the source of the compiler and libraries available to that match that release. Maybe not immediately when we do the release, but maybe at some point later. The sources do come already with the MSI releases, the CTP releases of F#. They're just under it's not under an open source license. So the question here is, will we also make it available under an open source license? And we think that's a very, very good thing to do for the major releases that we do. We think that's good for academics and for teaching, and we think there are lots of interesting tools that people might build, which become quite a lot easier to build if you have access to the F# compiler sources with open source licensing terms. Okay, so we're very positive about that, but we'll see where that goes over the next little while. Right, so I want to thank everybody for coming along. If there's any more questions, we'll wait a little bit and we'll see what take a few more questions. And Mohammed asks, is it easy to move from C# to use F#? And is it worth to use F# for the developer and the companies? Well, that is going to depend a lot on your problem domain. And it is easy to move from C# to F#. The language changes, but none of the libraries change. The tooling doesn't change. The runtimes don't change. The profilers don't change. The debugger doesn't change. Working knowledge of C# is very, very useful for the F# programmer. That doesn't necessarily mean you should move from C# to F#. There are many cases where you should not move from C# to F#. So you really have to judge when is F# right to use. We do get consistent feedback that F#, as C# developers learn F#, they learn a lot of new skills which they also find relevant to their C# programming. So I do think of all the languages for a C# developer to learn, F# is, in a sense, you know, it can challenge some ways of thinking about programming, but it is really worthwhile to learn F#. And I do hope that after this presentation, lots of people will go and take a look at the language and work through it and learn the basics of it, and then take a look where it can be used in practice. Okay, so as the designer and creator of F#, do you find yourself writing more trivial apps in F# now? So do you mean, so absolutely. I mean, you can use F# for anything. I think the question here is it only for these more complex engines? No, I use F# for everything. It's been a long, long time since I've written much C#. You can use F# as your primary programming language to solve all sorts of tasks, and I use it for all sorts of problems, from a 5-line script up to very large applications, many thousand-line applications. So I love it for all sorts of purposes. So Kostya asks about the previous answer. Is it appropriate to use F# for creating a data access layer using Entity Framework instead of C#? For that specific question, I would say C# is the right thing to use today. You can use Entity Framework from F#, but I think for that specific question, my recommendation would normally be to use C#. You can do it with F#, but I think if I had to give specific guidance, I would say use C#. I'm quite happy to give guidance about that if you need it further. Okay. Right. We'll just wait half a minute for any new questions that might come in.
Well, Don, I wanted to take the opportunity to thank you so much. This was really, really very informative and useful talk, and lots of demos, and I think everyone finds it very applicable. Even people who, it seems from the questions that there are a lot of people who never use F# and are considering it, and then there might be others who are more familiar, so it's a good mix, and I would be happy to have you here again in the future to talk more about F#.
That sounds absolutely great. I'd be very happy to come back. We're showing off some, actually related to the question that just came in about tell us what's coming for F#3. If you want to know about F# futures, then the thing to do is listen in to the PDC talk at 3:15 West Coast time on Friday, or watch I'm sure that'll be available online after the talk as well. And that's you'll be surprised and pleased, and it's quite a revolutionary addition to programming. And I think one of the most important things I've been working on, and a great example of the role of F# being a real thought leader for the platform as well. But I won't say anything more about it right now. Okay, Vladimir asks about. Hello, Vladimir. Great. Vladimir is a great F# contributor and is asking about the first-class events has many similarities with RX. Will they be merged with reactive extensions, or these two concepts will coexist? The strict answer is I think they will coexist, but we'll definitely. RX is a great framework, and you can use it with first-class events. F# events in .NET 4.0 are observables, and so you can use the RX libraries directly with F# first-class events. We did the design work in .NET 4.0 to make sure that those concepts can coexist and can be used fluently together in by making sure that F# events do implement the observable interface. Okay, so thanks very, very much again for everyone for coming. I think we'll draw it to a close there, shall we?
Yes. Thank you, Don. Maybe we go back and show just the people who may have come late some of our upcoming talks that we have in November. We have a couple of talks, one with Scott Guthrie, who is coming back every quarter to answer your questions, and another one about how to write clear code with aspect-oriented programming. That's November 3rd. And also we have December 1st, testable web parts for SharePoint. So again, thank you, Don, and thank you, everyone, for attending this LIDNUG talk, and see you in the next one.
Okay, thanks, everyone. Bye.